Okay, for the warm-up from yesterday, if you have 20 to the x equals 20 to the 5, what does x have to equal? It has to equal 5. Has to. Has to. Okay, the next one. We've got 10 to the log of 32. What happens here? The 10 and the log cancel out because this log has what base? 10, even though you don't see it, we know it's log base 10. And then our answer is 32. This one, log base 3 does not cancel with 9. What do you do first? Rewrite it as log base 3 of 3 squared with an x up there. Once you rewrite 9 as 3 squared, now log base 3 and base of 3 cancel, and we get what? 2x. That happens because log base 3 and a base of 3 are inverses. They undo each other, just like adding 5 and subtracting 5 undo each other. So here, ln is next to e, and what do we know about those? They cancel, they're inverses, so we get 4. Here we have e, and anytime you do e to an exponent. So this is e to the ln 8x. So what cancels here? E with the ln, and we get 8x. It's just that easy. So today, go ahead and find the page that looks like this. We, in section 5.6, learned how to find an inverse function. So I'm going to review how to find an inverse function. Step 1. If you have f of x, you got to change f of x into y. We've already done all these steps. So step 1, I'm just going to rewrite this as y equals 6 to the x. Step 2, when you have inverses, when we graph inverses, what do you know about the ordered pairs with inverses? Have we already learned? We learned it in section 5.6. When we graphed inverses, how do we get the points? We switched x and y. And when we rewrote the equation, in the equation, we switched x and y to get the inverse. So that's still the next step. So now I have x equals 6 to the y. From there, we solve for y. To solve for y. So I have to do something to both sides of the equation that cancels out a base of 6 and just gives me y when I'm done. And whatever I do to get rid of that 6 and just give me y, I have to do the other side, and whatever I do, if I do it to both sides, I do whatever I want. So from our warm-up and from our homework yesterday, what cancels out a base of 6? Log, not log 6, but log base 6 is the inverse of 6 to the power. So my next step, I'm going to apply log base 6 to both sides. My next step looks like this. Log base 6 of x equals log base 6 of 6 to the y. As long as I do to both sides, I can do whatever I want. So I chose something that would cancel out the 6 and just give me y. So I have log base 6 of x equals y, and then because the original question started as f of x, I'll just make it g of x and then. So the inverse of 6 to the x is log base 6 of x. The inverse of 6 to the x. This is just the original question. I just can't see it while I'm talking. You guys can see it still. The inverse of 6 to the x is log base 6 of x. That's important for when we go to graph them, which is after this page. These are inverses of each other. All right? Next. Same kind of question. Same steps. First says change f of x into y, but I don't have f of x, so it's already done. Yay. Next step says switch the x and the y. So I'm going to switch x and y, and I'm going to have x equals ln parenthesis y plus 3. And we're going to get y by itself. So you think about getting y by itself. The outermost thing, the last thing that's being done to the y is the ln. Because of the parentheses, the last thing being done to the y is the ln. So I have to know how to get rid of ln. I have to know its inverse. What's inverse of ln? E. But anytime you use e, just like if you go on your calculator, it's always e to the power. It's always e to the power. So what we're going to do to both sides is we're going to make an e. But this entire side is going to become an exponent. And then on the other side, e. This entire side, the entire side goes to be the exponent. As long as I do it to both sides, I can do whatever I want. And because of one of our warm-up questions, which I'm going to show you in a second, I'm allowed to take the base of e and apply it and make those exponents. Let me show you why. So going back to our warm-up, here, if x equals 5, then 20 to the x equals 20 to the 5. We just went the other way. But if x equals 5, then I can put in whatever base I want. Let's do. If x equals 5, I can put in whatever base I want. I could say 7 to the x equals 7 to the 5. Isn't that still true? As long as I do it to both sides. So I could say e to the x equals e to the 5. I could say anything I want like that. So I chose to use e on that one. I chose to use e on this one because ln and e cancel each other out. So now we have e to the x equals y plus 3. Is y by itself. So then subtract 3 to both sides, and we get y equals e to the x minus 3. And that's the inverse. The next two I added to help you out, give you more examples for your assignment. The next two are not on there. But we are going to do the last two on there also. So the next two, just find some spot to do it. You guys can do it. You can fit it up there. It's not that. It's not going to take up that much room. We're going to fit it on the side because that graph at the bottom, we're not really doing anything to. We're just looking at it. We are finding the inverses, just like we did for A and B. Same thing. Just I felt like we needed more examples that were different. Okay, so we first do what? Switch x and y. Switch x and y. And what's the thing that's being given to the y last? What's the first thing I need to get rid of so I can solve for y? What do I do to both sides now? Add 1. That's going to be my next step is add 1. Now, to get y by itself, I have to get rid of log base 2. So what is the inverse of log base 2? What cancels out log base 2? 2. You need to look at the warm-up again? There's no log base 2 here. There's a log base 3. We'll cancel out log base 3. Well, the squared part didn't cancel it out, just the base of 3 to some extent. To get rid of log base, we do have to do base. So what we're going to do for this one is we're going to take both sides and make these sides exponents. And I'm going to put 2 as their base. So I'm going to put 2 to the x plus 1 equals 2 to the log base 2 of 1. So I'm just putting base of 2 on both sides, raising both sides as the exponents. And that will allow me to cancel out the 2 with the log base 2. So now I have 2 to the x plus 1 is equal to 1. So I'm raising both sides to an exponent. Oops, D, we've got f of x equals 5 e to the x. So the first thing I want to do is just write that as y. And then what do I do to both sides? What do I do? Switch x and y. So I'll have x equals 5e to the y. We have to get y by itself, but we got to get rid of the furthest thing away from y first, which is what? The 5. So how do I cancel out a 5 that is being multiplied by e to the y? Divide it. So I'll have x divided by 5 equals e to the y. You could also write it as 1 if x equals e to the y, because instead of dividing, multiply by the reciprocal. Either of those is fine. So how do I cancel out e to the y? How do I cancel out the e? It is a base of e. What cancels out base? What cancels out a base with an exponent and gives me the exponent? We just did one right here. This had a base of 6. What canceled out the base of 6? Log base 6. So what's going to cancel out e? Log base e. Well, we just don't write log base e. We're going to do log base e. We're going to do that to both sides, but it's not called log base e. What is it called? ln, natural log. So we're going to do that to both sides. So I just did ln to both sides. That is the exact same thing as log base e, which is going to cancel out the e. We will get ln, you could have x over 5, or you could have 1/5 x, however you decide to write it. And then because that one started as f of x, I'm just going to rewrite it as g of x when I'm done. Are we following okay? Can you try the 2 on your own to see if you're understanding it? number 17 and 18. Try those to see if you're getting it. Okay, I put the answers up. Check to make sure you got them right. Anyone have a question? Anybody have a question? This is going to be another easy assignment. Question? Oh, you would look like this one. I didn't look like mine, so I had to go for a second. All right, the last section is graphing. Yay, graphing. In this picture, it's not colored for you. When I do my graphs today, I'm going to be doing colors if you're that person that likes to do different colors. What they've done is they're showing you an exponential in blue, which we've already studied. That was section 9. This is one you just graphed, 9-2. Okay. They're showing you that the exponential, this one is what kind of exponential that goes up? What kind of? Rule. Right. And then what they've done is they've taken all their x's and y's and switched them, so we now have the inverse. And then the inverse function is log base b. Where this was b to the x, this is now log base b of x. And everything has switched. The x and y have switched. The asymptote, which they did not graph, but I'm going to graph right now, the blue one is here at y equals 0. That's the asymptote. But for the red one, the asymptote is here at x equals 0. So I switched my x and my y for the asymptotes also. The domain used to be, for the blue one, the domain was all real numbers, and the range was y is greater than 0. Now when we switch everything, the domain is x is greater than 0, and the range is all real numbers. See how we switch those too? Everything switches. So how's this one different? What's special about this blue one? The exponential is what? Decay. And then when we switch it, now the log equation is still inverse. Everything switched is just going down instead of going up. So what we're going to do to graph these is we're going to build upon knowing the inverse and how to graph the inverse, and then we're just going to switch our x and y. That's what we're going to do. So I'm going to go through what I would expect to see in your assignment today. So take good notes. First thing I'm going to do is I'm going to think about my inverse. First thing I'm going to do is I'm going to think about my inverse. I'm going to graph log base 3 of x, but I don't know how to graph log. I know how to graph its inverse. What is the inverse of log base 3 of x? We just went over how to find inverses. Switch x and y. We just did a bunch of these. Switch x and y. We solve it for the other variable. 3. It's base 3, and then remember we were just graphing the other day? It's base 3. It's going to be, if you went and solved the whole thing like we just did, it's going to be 3 to the x. That's going to be the inverse. 3 to the x. Y equals 3 to the x. So log base 3 of x, the inverse is y equals 3 to the x. So remember we had key points? What do we always plug in for x? 0, which gives us 1, and 1, which gives us 3. And then if you want to plug in more, you can, but minimally you just needed 2 key points. And then we have an asymptote. When you're graphing these, it does not say anything about writing the asymptote or graphing the asymptote, but I'm telling you, do it. The asymptote for the inverse is always y is greater than 0 until we have transformation. The domain and range, let's review that. Domain is always all real numbers. Range is y. Oh, shoot. I was thinking ahead. I'm sorry, my asymptote is not y is greater than 0. What's my asymptote? Y equals 0. My range is y is greater than 0. Sorry about that. I was thinking too far ahead. So that's all the information that we needed to graph the inverse of this. So we'll go graph these key points. 0, 1, 1, 3. Asymptote. Connect it. If you need more points, you can find them yourself. And then what do we know about the inverse when we graph it? All inverse functions, every single time you graph them, what do they have in common? When you graph a function and its inverse. What do we know about a function and its inverse? It reflects over the y equals x line. So I just dashed that in. Now I'm going to write down all of my inverse information. So this information now is for y equals log base 3 of x. So all my information now is the regular function, which is the inverse of this one. And this is where I changed colors. So you switch every x and y. We have now 1, 0. You now have 3, 1. Our asymptote, we switch x and y. So it says y equals 0. I now have x equals 0. Domain, I switch x and y. So this one's going to be x is greater than 0. And my range, I switch x and y, so it is all real numbers. Just switch all the x's and y's. We'll go graph them. So my asymptote is at x equals 0. So where this one was on the x-axis, this one is now on the y-axis. That's where x equals 0 is. Ordered pair, 1, 0, 3, 1. If you need more ordered pairs, find some more, but you just use the asymptote. It looks like it reflects over the y equals x line. I don't even know what does that. If I knew, I'd stop doing it. Okay, let's try the next one together, which is number 19. 19. So the first thing that you want to think about is the inverse. So that's where I'm going to start. I'm going to start with the inverse. What is the inverse of log base 2 of x? Y equals 2 to the x. So key points. 0, 1, 1, 2, asymptote. What's the asymptote? Y equals 0. So I'm going to graph my asymptote, y equals 0. I'm going to graph 0, 1, 1, 2. If I need more points, I can find them. And then I'm going to do the log, the inverse, the log. I switch everything. So I switch everything. Am I making it too easy for you? There's just going to be a review. Next week. Correct. So I will not make a quiz Tuesday because that's just okay. I did put a little thing over there in the corner. What if instead of y equals log base 2 of x, what if I gave you y equals log base 2 of x plus 3? What would that tell you, this blue one, compared to my purple one? What would that tell you is happening? Do you know if it's up or do you know if it's left? Up is correct. don't go get your classmates just because they could do things. But if it were left, it would look like y equals log base 2, and then you'd have x plus 3 with parentheses, because otherwise there's no way of knowing unless there's parentheses there. So this one is up. So how would I graph this blue one? I would what? Which up? The purple one, or the purple key points. Yeah, I would just take this one and go 1, 2, 3. I take that one and I go 1, 2, 3. What about the asymptote? Can I move the asymptote up 3? Right. Like, I mean, you can, but it goes forever, so it's not like you're doing anything. So I would just graph it right there and use the same asymptote. So there's 2 questions in homework that say something like, use transformation. That's how you use transformation. All right, we're going to try one more, and that is number 21. I'm going to let you get started on it, and then I'll jump in and go over it with you. So 21. Try number 21. Notice how I have not used the calculator yet. A lot of you are writing 1/2 without parentheses. If you write it without parentheses, technically you're only doing 1 to the x. Like if you were to type it in your calculator, it wouldn't work right. So I write it the way that you would type it in. If you were using a calculator, which we don't need now. Oh, Aiden, it was all you, buddy. So my key points for this one are going to be 0, 1, and then 1, 1/2. And because this b value is less than 1 but greater than 0, what kind of graph is this one going to be? This is going to be decay. Because when I go to graph 0, 1, and then 1, 1/2, like those are so close together, I might almost feel like I need another point. These are the key points, but you are more than welcome to add extras. What extra point would make sense for me to add here? -1, 2. That is not one of the key points. That's just extra. So if I ask you what the key points are, that is not a key point. That's just extra. That's not one of the key points. But if I graph -1, 2 now, I just kind of like have a better idea what the graph looks like. My asymptote is y equals 0. So if you're graphing your inverse point, I didn't like graphing 1/2 of 1. That would bother me. So that's why I was happy I had that extra point there. And then if you're looking at the y equals x line, they should look like they reflect over it. Even though they're like on top of each other somewhere. So the last 2 pages, when I write and print in your packet, I grabbed what I just printed, but apparently this is really printing for calculus stuff right at the same time. So like it's really here. Oh no, that's calculus.
Oh, I knew I'd get to calculus one day.
Yeah. So we won't be doing the last 2 pages. Sorry about that. That's 2 years ahead there.
Wait, so she printed at the same time, so it printed your stuff and then on the back?
No. Like, it was like single sheets, and I just like grabbed it and I looked, and I was like, threw it out here, and then later I was like, oops.
If we do it, like, if we get one right, we get extra credit.
If
what?
you'd like to see what that looks like, don't eat waste for time. Please, if you're going to do that much effort into math, put it in out.
I will.
Okay. Dang. Alright. So I have your assignment. I'm going to pass out some graph paper. Stop the video.